Okay, so we're going to look on to the rules for logs and exponentials. Okay, well, it's rules for logarithms. We already have the rules for exponentials. Those are from National 5. It's the indices laws, and these are, like I said previously, the exponential graph and the logarithm graph are linked together. The rules for logarithms are linked to the rules for exponentials. Okay, so the first rule that we have, so rule number 1, is that log to the base a of 1 is equal to 0. Okay, so no matter what our base is for our logarithm, at x equals 1, y is 0. Okay, and this is linked, the exponential law that this is linked to is we know that a to the 0 is equal to 1, and we can rearrange that, and that gives us our log to the base a of 1 equals 0. Okay, so those are linked together, so that's just a rule of logarithm graphs, is that they always cross the x-axis at 1 unless they've been shifted by anything else. If it's just log to the base something, it always crosses the x-axis at 1. Okay, so rule 2 that we have of logarithms is that if we've got log to the base a and we put that a into our function, we get that it's 1. And again, that is linked to our exponential law of a to the power of 1 is equal to a. And again, that just rearranges, and that would give us log to the base a of a equals 1. So log to the base anything of that same thing is just 1. And that gives us a nice point when we're plotting log graphs. So we know that at the base value is always going to go through 1. Okay? So rule 3 is where things start to get a little bit more complex, not overly so, don't worry. So rule 3 we have is that log to the base a of x plus log to the base a of y is equal to log to the base a of x, y. This one, again, they all come from our rules for exponentials. And the one that this is linked to is the a to the m times by a to the n is equal to a to the m plus n. It's not as easy to kind of see the link between these two, but it is there, I promise you. Okay? But the examples of this are quite simple. For example, if I've got log to the base 10 of x plus log to the base 10 of 7, I can combine those together, and I know that's going to be log to the base 10 of 7 times x, or log to the base 10 of 7x. We can also use this the opposite way, and we can start with something and we can split it up. And this can become useful if you've got a mix of letters and numbers and things in something that will work quite nicely. And we can combine it kind of with rule 2. So if I had log to the base 7 of 7y, using 7 again, but that's fine. I could say that's the same as log to the base 7 of 7 plus log to the base 7 of y. And we know that anything which has got the same base and number inside the log is just 1. So it would just be 1 plus log to the base 7 of y. Okay, moving on to rule 4. Okay, right, so rule 4. This is, again, it's going to be linked to one of the ones that we've got for our exponentials or our indices laws. And this is log to the base a of x over y is equal to log to the base a of x take away log to the base a of y. Okay, remembering this one is kind of written the other way to the previous ones, but remember these can go either way. This means we can separate our logs or we can combine them together depending on what we need to do for our question. Okay, and this one is linked to our a to the m over a to the n equals a to the m minus n. Okay, so some examples for this one. If I've got log to the base 10 of 50, take away log to the base 10 of 5, I can say that's the same as log to the base 10 of 50 divided by 5, which is equal to log to the base 10. 50 divided by 5 is 10, and then because we've got log to the base 10 of 10, we know that's 1. So again, we're going to have to combine all these laws together, just like we did with our indices laws in National 5. They're all going to have to come together. Right. Okay, so our last rule is the one that's kind of the most abstract to kind of our exponential law. Rule 5, if we've got log to the base a of x to the power of n, that is equal the same as n times log to the base a of x. Okay, the one this is linked to is a to the m all to the n equals a to the m n. That's the kind of law that it's associated with and where it's kind of been derived from. I'm not going to show you where it's been derived from, but that's where it's come from. Okay, so examples of this one. We can again use this and go either way. First example, say if I have log to the base 4 of 4 to the power of 12. This is going to be quite simple. We know we've got that 4 to the 4, but we can't get rid of it yet. So we can say that's equal to 12 log to the base 4 of 4, which is 12 times 1, which is just 12. Okay. Another example that we could use would be if we've got half log to the base 5 of 625. Okay, so this is going the other way. So we're going to have log to the base 5 of 625 all to the power of a half. We should know that a half is the same as square rooting. So then we get log to the base 5, the square root of 625 is 25. Okay, then we're kind of using the same rule again. We know that 25 is 5 squared. Okay, and then we can bring that 2 down the front, so we get 2 log to the base 5 of 5. And log to the base 5 of 5 is just 1, so we can simplify it and we know that that's just 2. Okay, so it's using all of these laws together. Okay, but don't worry about it. Let's have a go. We're going to do one example that's kind of a combination of using all these kind of laws all together. Right, okay, so the question I'm going to go for is just simplify. And we're having to simplify 2 log to the base 4 of 16 plus 3 log to the base 2 of 8 minus log to the base 2 of the square root of 8. Right, so we are going to want to get rid of our logs, and one of the easiest ways I think for us to do this is going to be, because 16 is 4 squared and 8 is 2 cubed, we can kind of do stuff with those, which is going to help us out. So we're going to get 2 log to the base 4 of 4 squared plus 3 log to the base 2 of 2 cubed minus, and then we know this is log to the base 2, this is the same as 8 to the power of a half, because we should know that the square root is just the same as a half. So then we can take these down. 2 times 2 gives us 4 log to the base 4 of 4 plus 3 times 2, which is 9, and then it's going to be log to the base 2 of 2, and then we've got minus a half log to the base 2 of 8. Okay, we're getting there, not quite yet. So we have 4 here because it's just 4 times 1 plus 9. So we've got rid of those first 2 logs, but the last one we need to kind of deal with. So again, we can use our fact that we know that 8 is 2 cubed. which gives us log to the base 2 of 2 cubed. And then we can take that out at the front again. The 4 and the 9 we can add together, which gives us 13. Take away, and then it's going to be 3 times a half, which is 3 over 2. Log to the base 2 of 2. We know log to the base 2 of 2 is just 1 though. So then we're going to get 13 take away 1.5. So that's going to be 11.5 as our answer. Okay, so the logarithms, it's just about knowing our rules and working through with them and just kind of methodically going through. Okay, right, so next we will be looking a little bit at using log with the base of e.